Hello everyone. Today I am going to talk about something that I really find fascinating. World models for autonomous driving. This is based on a very comprehensive survey that came out in the early 2025, and it covers how self-driving cars are learning to predict the future. And yes, you did heard it right. Hear it right. Literally predict the future. So let's drive in. So the first and foremost, the challenge we faced, the challenge we are facing. So let me set up the problem. When you are driving, you are constantly predicting what's going to happen next. You see a car at its signal, you predict whether they are going right, left, front, or you see a pedestrian near the crosswalk, you predict if they would walk or they won't step out. So your brain is continuously running these simulations all the time. Self-driving cars need to do the same thing, but here is the challenge. They are processing about 4 terabytes of data every second. That's through all the sensors, which would, in real world terms for everyone, would be downloading thousands of HD movie per second. But that's not the hard part. It's it is not processing that data. It is using that data to predict what's going to happen next. And that's where world model comes into play. So what is a world model, you might ask? So a world model is basically car's imagination. It's like an AI system that learns to predict how the world will evolve over the next few seconds. Instead of reacting to what's happening right now, the car can imagine multiple possible futures, and then it could plan accordingly. Think of it as like playing chess. You don't just look at the current board position. You think about you think several moves in the future ahead. World models do the same thing, except it is not chess pieces. It's literally predicting cars, pedestrians, cyclists, sometimes even random plastic blowing over the road. Uh, the real cool part here is these models can learn mostly through their own, uh, through something called as self-supervised learning, which I will explain more in a bit. So the architecture of the basis, we call it as three-pillar architecture. The survey organizes world models into three main pillars. Think of these three interconnected pieces that all work together. First, we have the physical world generation, predicting what the scenes will look like in the future. Second, behavioral planning, deciding what actions the car should take. And third, the prediction planning loop, how these two processes interact with each other. So let's get into each one individually. The first pillar is about generating predictions of the future physical world. There are actually several ways to represent this. Camera-based predictions, literally generating future camera frames. Uh, the system that creates a short video clip of what uh, things and what the views would look like in a few seconds. Uh, these use similar AI tools of what you might have seen all around Instagram and all the social media apps, Sora, for example. The second is bird eye view or BV. That creates a top-down view, kind of like looking at Google Maps or the new era models, car models of you call it 360 view. This makes it's much more easier because you have the spatial relationship between the objects. Uh, uh, and then there is 4D occupancy forecasting, which is most detailed but also needs the most computational uh, power, and it's very expensive. It divides the world into tiny cubes and predicts which cubes will be occupied at the future moment, and so on and so forth. So model system can predict up to like 10 seconds in the future, though obviously the accuracy drops as you go much further in the future. The second pillar being The behavior planning. Uh, so, what action would you take on whatever is predicted? Uh, this is where behavior planning comes in. The car needs to decide what it should actually do. There are two main approaches for this. Rule-based planning, use explicit traffic rules and safety constraints. It's really sophisticated flowchart, like what if this happens and what if that happens. Then there are a few disadvantages. It could get very rigid. It could struggle with the usual situations if not in the rule book. But it's very predictable and interpretable, so that's an advantage. Learning based on planning uses neural network that learns how to drive by watching human drivers or through trial and error in simulations. This is more flexible, but also more of a black box. You can't always explain why the car made a specific decision, but well, it made a specific decision, so live with it. Most modern systems actually use a hybrid approach. They use learning for the complex stuff, but the hard coded is safety constraints. You definitely don't want your AI deciding to run a red light or just run over a human, uh, which is occasionally acceptable, not the second part, the first part. But even when you could see it, you could see human driver do that as well. So just learn from that. The third pillar being the prediction planning loop. This is where it gets real interesting. Uh, Prediction and planning aren't separate steps; they are deeply interconnected. When you predict how another car will behave, you're masking assumptions about what they think about you as well. So you are planning your actions based uh, on what you think they will do. They are doing the same thing about you. So it's more like a recursive prediction thing. Uh, Advanced world models actually model this interaction explicitly. Um, they predict multiple possible futures based on different actions our car might take, then pick the action that leads to the best outcome. Some systems even use reinforcement learning to optimize this, learning through millions of simulated drives, which action sequence lead to safe and efficient outcome, the reward. The latest approach also uses memory augmented architectures, which is basically the car is working memory of the car has the working memory of recent events. This helps in the situation like four-way stops where you need to remember who arrived first. Done with the three triple architecture. Now we come to uh, how these models learn. Uh, This was the most surprising part for me. I thought these systems would need massive amount of systems, would need massive amount of labeled data, human annotations, every frame. But that's not how the modern system works. They use self-supervised learning, the one I talked about before, extensively. The basic idea is very brilliant. Uh, Show the model a video sequence with the last frames hidden. Ask it to predict what the next hidden frame is, then reveal the actual frame, and well, let it learn from its mistake. Repeat this billions of times across millions of driving scenarios. No human labeling required. Uh, the model just learns the physics and the pattern, the traffic by watching it all happen. It learns that the car don't teleport, that pedestrians usually stay on the sidewalk, the object don't just disappear. They also use multi-model pre-training, uh, training on cameras like LiDAR and radar data simultaneously. Uh, each sensor has different strengths, so learning from all of them together builds a more robust understanding. Let's say. So here is something very clever. Once you have the world model, you can just use it to generate synthetic training data. You can create rare scenarios that don't happen often, but well, you could train your data on that in the real data, but that the car needs to know how to handle those. It's like a flight simulator for self driving cars. So the performance and the matrix. Let's talk about the actual performance. How I am usually skeptical of AI hype. Uh, State of the art model, let's say, can predict vehicle trajectories with errors under half a meter at 3 seconds into the future. Uh, that might sound like a lot, but at highway speeds, they are covering 30 meters per second. So being off by half a meter, 3 seconds is actually quite good. The 4D occupancy thing I talked about before. The models are achieving like 40, 45 to 50% accuracy for 3 second predictions. That might not sound amazing, but remember, this is predicting the exact 3D space that will be occupied hundreds of timestamps in the future. It's an incredible hard problem. Where things get challenging is with long horizon predictions, like beyond 5 seconds and rare events. Mhm. The model tend to predict average behavior, which means they sometimes miss one car that's going to do something very weird. Uh, this is actually a very fundamental challenge because, well, unusual events are rare. In general, it's rare. So obviously, it should have to be for the training data as well. So Well, the major challenges we are facing. Let me be honest about challenges because, well, they are significant. So, starting with, let's start with computational cost, which is very brutal. Uh, Running a full world model in real time requires serious hardware, multiple high-end GPUs, just for predicting systems. This is why only companies with massive budget, and I say massive budget, can deploy these scales. The sim to real gap is still a very big problem. Models trained in simulations often fail in the real world because a simulation always miss something. Well, that's why it's called a simulation to start with. Maybe it's how the shadows fall or how wet pavement look like works. Again, a very rare event, but it's still very hard. The long tail of the driving scenarios is incredibly long. You might encounter something you have literally never seen before, and the world model would obviously struggle over there. Uh, so, my personal take over all of these things. So, hmm, I think world models are going to be the foundation of autonomous driving, but maybe not in a way people expect it to be. There are trends towards the end-to-end learning, but I actually think explicit world modeling is very crucial for safety. You need to know what the car thinks and is going to happen, so you can verify its reasoning at least. I predict we'll see hybrid architectures become dominant. Word models for predictions and understanding combined with explicit planning algorithms that have hard-coded safety constraints possible. Like within 2 3 years, I think we'll see models that can be reliable and reliably predict 10 seconds in the future, ahead of the common scenarios at least. Uh, the big breakthrough will be in handling rare events, probably through combining learned models with, well, rule-based reasoning for unusual situations, and again, the same thing, rare events. What really excites me is using the word models for training and simulations. Once you really have a good model of how traffic behaves, you can generate infinite training scenarios and you could test your driving system against every weird edge case you could think of before ever putting it in the real world. Talking about the real world, what is the real world applications? Like current real world applications. So the companies like Waymo and Cruise are already using forms of world models in their robotaxi fleet. Tesla's self-driving systems, well, it incorporates predictive models, though the exact architecture is still not public. So the technology is real and it's becoming deployed, more and more deployed day in day out. Though we are still years away from having fully autonomous vehicles everywhere, we are on the right path. So, well, the key takeaways first, one of the one would be world models enables autonomous vehicles to predict rather than react. Second would be the triple architecture I talked about. Third would be self-supervised learning, how the models usually learn. Four would be the real world progress. And five, this technology will likely be the foundation of the future of autonomous driving, but in a hybrid architecture rather than purely end-to-end systems. So, yeah, that's about it about my that's my video about the paper I chose as a short story system. So, if you dive deeper, I highly recommend reading the full survey paper by Feng 2025. It's on ARXIV and it's surprisingly readable for considering it's a technical paper. I have written my own Medium article. I will give you the link below. And well, thanks for watching. Thanks for hearing. More like thanks for hearing. Uh, if you have questions and want to discuss about this, feel free to maybe just use my mail. Feel free to use my mail, and if you know me, obviously just text me. The interaction of AI and autonomous driving is something very fascinating to me right now. I think we are going to see some amazing advances in the near future. I will leave you with that. So, yeah, thank you so much.